Hey gang, today we're going to be graphing some inequality word problems. Please have your graphing calculator ready because we will be using it to help us graph these equations more easily. All right, so let's take a look at our first example. Here we have Nathan has at most 30 minutes to complete his math and science homework. Write and graph an inequality that will represent the amount of time he can spend on math, which is going to be x, and science, which will be y. Explain what the shaded region of the graph represents and state one solution. Okay, so this is a very simple equation. We know math is x, and science is y, and he cannot spend more than 30 minutes or at most 30 minutes, so less than or equal to 30. We have to rewrite it in slope-intercept form, so we subtract x from both sides. We get y is less than or equal to negative x plus 30, which is a pretty simple equation to graph, but I can still pull it up on my calculator here. If I go to y equals and type in negative x plus 30, and pull up my table, second table, I have a table of all of the solutions that will be on the line. So this is helpful because I can find my x and y intercepts very easily. We should know that the y-intercept is 30 just by looking at the equation, but here it is in the table, 0, 30. And we can also find the x-intercept if we scroll down. So the x-intercept is 30, 0 as well, but that's where it will cross the x-axis rather than the y-axis. So that's like saying if this person spent 30 minutes on math, they would spend no minutes on science, where the y-intercept is saying if they spent 0 minutes on science, they could spend 30 minutes on math. Okay, and then all the other numbers are the solutions in between that will fall on the line. So we need to set up our axes here. Remember that x is the time for math, and y is our time for science. Now, it'd be really nice if I could label each box as 1, but there's not 30 boxes or units here, so we're going to have to modify our scale. So let's make this 0, and let's count every other box as 3. So this is 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And we can do the same on the x-axis. And now this is actually very easy to graph because it's just a slope of 1. So we could start at 30 and go down 1 over 1. Or we could look at the table and fill in just the 3's if that helps. But remember, going down 3 and over 3 is the same as going down 1 and over 1. But if we just wanted to plot the 3's, so we got 0, 30 is our first point, we could go and do 3 and 27. So if you're really bad at slope intercept, this would really help you. Then we go to 6 and do 24. 9 and 21. And you see we're really going down 2 over 2, but that's equivalent to 1. We're going down 6 over 6 if we're using our slope. Then 12 and 18 and so on. So you've now gotten enough that you can see the pattern and you can continue the points. So that function on the calculator is very helpful, especially if you're not really understanding slope-intercept form. The calculator can do it for you. Now, since we have less than or equal to, we draw our solid line. Use a straight edge or a ruler, nice straight line through those points. And since it's less than, we want to shade underneath the line. Remember to draw it neatly so that it's obvious that you understand where the solution set is. So now every point in that shaded area is a solution, including the points on the line because it's a solid line. So we have to explain what the shaded region represents. So in this case, the shaded region represents all the possible times Nathan can spend on math and science homework that are less than or equal to 30. I'm going to add 30 minutes. So now we can state one possible solution. So obviously all those points on the line are solutions. I'm going to state one that's in the solution set but not on the line. So for example, maybe he didn't need the full 30 minutes and he worked for 12 minutes on math and about 16 minutes on science. So this is one solution because it's in the solution set. 12 minutes for math and 16 for science. And of course, if we wanted to prove that that worked, we'd plug it back in and do 12 plus 16 is less than or equal to 30. 12 plus 16 is 28, which is less than or equal to 30, proving that it is a solution and will satisfy the equation. All right, let's take a look at a second problem. Okay. 2. Adult passes for World Water Park are $30 and children passes are 15. A company is buying tickets for its employees and wants to spend no more than $630. Write and graph an inequality that will represent the amount of tickets they can buy for adults X and children Y. Explain what the shaded region of the graph represents and state one solution. So like we did before, we need to start by writing our equation. So again, we know that adults are X and children are Y. Adults cost $30, children cost 15, a total of 630. So we have 30x plus 15y has to be no more than 30, so less than or equal to 630. All right, now we have to solve for y, so we subtract 30x. We get 15y is less than or equal to negative 30x plus 630. We divide by 15, and we get y is less than or equal to negative 30, negative 2, not negative 30, negative 2x plus 42. All right, so we have our equation. Now we have to set up our graph. So in this case, we want to do adults on the bottom and kids on the y-axis. And I'm going to pull up that table first to find the x and y intercepts. Obviously, we know the y-intercept is 42, but it might help me use more space if I can find the x-intercept as well. So I go to y equals, I clear this, I put in negative 2x plus 42, second and table. And now, as we know, the y-intercept is given as 0, 42. And if I scroll down, I can look to see where it crosses the x-axis. And it crosses at 21, 0. So that means my y-axis needs to go up to 42. My x-axis only needs to go over to 21. So to do that, I'm going to count by 4 every other or 2 each box. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and 44. 42 would be right here. So that's my y-intercept. And then my x-axis, since I only have to go to 21, I can do 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. So 21 is right here. So really, I have 2 points. I could make my line from them, but I want to add some more points in the middle. So if I go back up to the start of my table, I don't have to graph every one. Maybe I just want to do the evens to make it a little faster. So 2 is going to be 38. 4 is going to be 34. 6 is going to be 30. And from there, I can see the pattern. I'm really going down 2 for every one, but in this case, I'm going down 8 and over 2, which is, whoops, down 8, yeah, and over 2 does not give me -2. Something seems wrong. Did I graph it right? 0, 42. Oh, I know what I'm doing, down 4, not down 2. Down 4 and over 2, which is -2. So I'm going to continue my pattern. And it would go here, but then cross there. And I need a solid line through those points because it says no more than, so that's including the 630 and including the points on the line. And no more than again means less than, so we shade under. And there, all the points in the shaded region and on the line are solutions to our problem. But let's explain the solution set some more. So in this case, explain what the shaded region of the graph represents. So the shaded region represents all possible ways of purchasing adult and children tickets spending no more than $630. Okay, so that should seem obvious, but I want to make it clear that you understand what that solution set represents. So then state one solution. So anything inside here would work. I would assume that more people, more adults are going to come because it's from our business. So maybe 14 adults come and 14 kids come. So this would be one possible solution, 14 adults and 14 kids. Or maybe it winds up being an all adult affair. So then there, we could say 21 adults and 0 kids. Those are all possible solutions. I picked 2 on the line. You didn't have to pick 2 on the line. So this could also be a solution right here where 12 adults attend and only 8 kids attend. All right, so hopefully you understand how to come up with the equations and then graph them, and now also use your graphing calculator as a tool to help you graph those points because you're going to be on your own on the next 2 problems, numbers 3 and 4. You can work on your own or with a partner. Please check in with me so I can verify that you've got it correct before moving on to your exit tickets.